right, getting into some more fun with Algebra 1. We are on lesson 6.5 today, and we are adding and subtracting fractions. Our essential question is, can you add and subtract algebraic fractions? So the key word here is obviously algebraic, because now we're moving into some different fractions that we get to work with. So let's look here at example 1. Example 1, notice that we have a common denominator, which is so user-friendly for us. Our common denominator is 8. So the first thing I do is I just write my vinculum, and even though it's not straight, and I write my common denominator is 8. But one thing we have to notice is that this little negative, even though there's no parentheses, all of this is being subtracted. So I'm going to take this negative and distribute to the 5a and to the negative 4. So on the top of my vinculum, I would rewrite 6a minus 1 minus 5a plus 4. And we end up, again, the common denominator is 8. 6a and 5a add up to be a. Negative 1 and 4 add up to be 3. So we just have to be aware of this negative right here. If it's being subtracted, we want to make sure that distributes through both or all of the terms if there's 3 terms. So that's good. You guys know how to do this from Algebra 1, so we're going to continue to do it. All right, you should know what to do with something like this. On the bottom, we have that y minus 5 and that 5 minus y. We saw this in chapter 5. Do you guys remember what we had to do? Good. Remember we factored out that negative 1, and instead of putting it here, I'm going to erase that, I put that negative 1 here and change this to a positive. Now what that changes is it changes all of either the top or the bottom, but I'm going to make the bottom change because I have y minus 5, and here I also have y and a negative 5, which is y minus 5. So I wrote those with arrows the way I read them. So now I know my common denominator is y minus 5. On the top, now we could just add together. I'm not going to rewrite it because I can just add from here. 4y and 3y is 7y, and negative 2 and positive 1 is negative 1. So my final answer is 7y minus 1 over y minus 5. All right, this one we're going to have to change things around a little bit. We do not have a common denominator, but we learned how to do that. So I know the common denominator between 3 and 12 will be 12. So I'm going to draw my vinculum and write 12. Now, what do I have to do to the left side to make 3 be able to go into 12? I know I have to multiply the 3 by 4, but remember we can't just multiply the 3 by 4. We have to multiply everything through by 4 over 4. Again, I can multiply anything through by 1. 4 over 4 is equivalent to 1 and not change its value. So now on the top, I have 4m. And remember this negative is going to go through, so I'm going to distribute this through minus 6m minus 3. So on the bottom, I still have that 12. 4m and negative 6m is negative 2m. And minus 3 is our answer. All right, now we've got some with variables. So I have 6y on the bottom of the left and 12y cubed on the bottom of the right. So what would be my common denominator? Good, it would be 12 because 6 goes into 12 and 12 goes into 12. And then I have 1y and 3y's, so remember the least common denominator, I want the greatest amount of variables, so I'm going to actually have 3 of those y's. So, to multiply 6y to make it something 12y cubed, I need to multiply by 2y squared to get to 12y cubed. Again, I have to multiply it through by 1, so that would be 2y squared over 2y squared. So on the top, I have 10y squared minus 7 And in the denominator is 12y cubed. So it looks like my answer is 10y squared minus 7 over 12y cubed. Great job. All right, we're going to do one more. And what do you think I'm going to tell you? We have to do what first? Good. We always, always, always want to factor first. So I have this little binomial of n minus 3. And I know that n squared plus 8n plus 15 can factor to be pretty nice. What are the factors of 15 that add up to be 8? That would be n plus 3 and n plus 5. So, because the n plus 3's are common with the denominator, we're only going to use those once. So I need one n plus 3. And here I have an n plus 5, so I need to use that n plus 5, but notice on the left side I don't have that n plus 5, so what do you think I need to multiply by? Yes, by 1, so I'm going to use n plus 5 over n plus 5. So let's get to work. N times n is n squared. N times 5 is 5n. But I also, watch that sign right here, I also have plus n plus 9. So we have to find our final answer. I'm actually going to write it in purple. On the bottom, I still have n plus 3, n plus 5, and on the top, it looks like I have n squared. 5n and n add up to be 6n and 9. Now, what do you think has to happen? Do you think I'm finished? I'd like to say, wow, we're done, but guess what? We're not. Because most of you know that the factors of 9 that add up to be 6 are going to be 3 and 3. So this can continue. So we always have to watch for it. Sometimes it doesn't happen, but sometimes it does. So remember that this can continue to factor. On the top, I know the factors of 6 that add up to be 9 are n plus 3, n plus 3. And on the bottom, I have n plus 3 and n plus 5. What do you think can cancel out here, guys? Good. The n plus 3's can cancel out. And my final answer is finally n plus 3 over n plus 5. Great job.